right, so we always go over these right after so you can see what the answer was. And major function of the endocrine system, was it distribute blood, break down and absorb nutrients, produce urine, or regulate body functions by making hormones? Definitely body functions by hormones. Cardiovascular system, that's the blood. Starting you all off easy with a few. What is it called when you're lying flat on your back? Ventral, supine, prone, or plane? That's supine. That must be, which plane divides the body into a top and a bottom half? It's transverse, exactly. And the most basic level of structural organization, organ, tissue, cellular, chemical. It is chemical. Chemical is the lowest. All right. So again, these tests aren't supposed to. So those aren't supposed to stress you out or anything. Just get you some points, get you thinking about it. All right, so before we get started with the actual chapter 1, I'm just going to have you write down some expectations for your group. Kind of how you want to do things you expect from your group mates for the lecture and for the lab for this unit. So if you just 2 minutes, jot a few things down just on your own, and then we'll let you discuss them and come up with kind of a contract for your group. All right, so now you're going to talk to your group, discuss what you put down, and come up with a common list of things you all agree to with your names, and then you're going to turn it into me. All right, so thanks for that. Hopefully you kind of remember what you all agreed to there for your group. And what's important to realize, I don't grade on a curve, so you're basically a team trying to get all of you to succeed as best you can. And what do you think who knows things the best? What's the best way to know something? Well, practice, yeah, definitely. But teaching it to someone? So that's why I know this stuff so well. It's not because I read it in books a whole bunch of times, or it's because I have to teach it. So you really, really have to know it to teach it. So in your group, if you get something really well, and you're teaching it to someone, there's no way you're going to forget it. You're going to get it on the test and be like, yeah, I explained that to 3 people and they understood me. And it's going to be in your head for forever. So think of it that way. Be nice to each other. We don't usually have problems. All right, so let's start with a quick question. You should have your little remote clicker things around. There may be an extra one laying around on the wrong table. Let's see. All right, so everybody put C there. Exactly right. Just make sure you're getting those. The mid-sagittal plane, equal left and right sides. All right, so a lot of times you want to kind of describe where something is in comparison to somewhere else in the body. This can get a little bit confusing if you're trying to use just regular words, like it's in front, below. So for anatomy, we've invented all these other words to use that are more descriptive. And you'll see that throughout the textbook. They'll start using these words, assuming that you do actually know what they mean. So these are the ones we're going to practice with. So you've got anterior and posterior. Those are pretty easy to remember. Distal and proximal, you really only use those for the limbs. So you're talking about like something on the leg is distal compared to something else on the leg, or something in the arm compared to something else in the arm. So you wouldn't say something like the liver is proximal to the heart or something. That doesn't really mean anything. Just the things hanging off of you. Medial and lateral, that's closer to the midline. So something that's medial is closer to the middle than something that's lateral. And then superior and inferior, that's just top of the body, bottom of the body. And one thing I want you to notice, you had anatomical position on there. That's where you're standing like this. And so for these terms as well, you use that position. So think about, those fingers would be standing like this when you're talking about. So then if you're standing like this, is your thumb, would you say it's lateral or medial to your little finger? It'd be lateral, because this is the position we always kind of compare things to. And we'll put that back up because you're going to practice with it. But first, let's see what you got here. So which of these is incorrect? All right. So nearly everyone said E, which is what I was thinking the answer was, because your fingers are distal to your wrist. But then this group brought up, they said, well, your eyes aren't really completely above your nose, right? 'Cause your nose starts here. So you could argue that A would be incorrect too. I didn't really think about. I was thinking just like the bottom of your nose, but I didn't write that. So technically A and E would both be wrong. And so basically what you're going to do is practice this. And the way we're going to do that is I've got a little worksheet for you to fill in. And basically you're going to make true-false questions for other people to solve. So there's 5 of them, and I'm going to put that picture of the person up there so you can look at what all these mean. You can make all of them true, all of them false, 3 true, 2 false, whatever you want to do. And this is individual. You're just going to make these on your own. Try not to use too many crazy bones since we haven't studied them yet. Stick to things that people should probably know. All right, so let's talk about that for a second. So a few things that came up. First, if it has to be, they have to be different. So you can't, if there's 2 things that are right in the middle, you wouldn't say they're medial to each other because they're comparative terms, right? So you wouldn't say your nose and your mouth are medial to each other because that doesn't make any sense. They're both in the middle. So instead it'd be like the nose is medial to the eyes or the mouth's medial to the ears. And then kind of the second thing that came up is it does matter what order it's in. So like the first thing compared to the second thing. So for example, the shoulder is proximal to the wrist and the wrist is distal to the shoulder. So you're saying it's farther away than the next. It's kind of how those work. Did you come up with any other ones or something someone asked you that you thought was wrong or confusing or anything?
I said the nose is lateral to the ear, but I probably should switch those 2, right?
Well, if the nose, so you said it was false, right?
That's what I'm asking. If I would have switched it around, it would have been true. Like if I would have said the ear is lateral to the nose, then that would be true.
Right. So
okay, so I need to switch those 2.
Right.
Okay.
So the ear would be lateral to the nose.
Okay.
So you use the term medial, like as referring to the face, it wouldn't just be like everything is like to the midpoint of the body in general? Or
That's exactly right.
oh, okay.
So if you drew a line from the middle of the top of your head all the way down to, I guess, your pelvis, then you could, anything outside of that would be lateral, anything closer to that line is medial. And once we get more into it, you can even have like the medial part of the liver compared to the lateral part of the liver is how you can use it too. So you zoom in.
How will they distinguish like left and right sides, or is that something that you can't tell here?
Just left and right.
Okay.
And there's a few more in the book, but these are the ones we'll stick with. those terms. There's also like dorsal and ventral, but you don't usually use that too often. Be more anterior and posterior. They use dorsal and ventral more for quadrupeds or fish, or not for us. So we have some other stuff to go through. And the first thing is all the different body cavities that are in the body. And I'll make you a little concept map up here because it can be a little confusing to keep them straight. So the first one is you can divide it into two really broad categories. And one's the posterior, and it's encased by bone. So you can see it up there in orange. So if you're posterior. And so that's the spinal cord and the brain cavity. And then in the front is what we call the ventral cavity. So it's all the way from the heart down to the bladder, basically. So this is brain, spinal cord. And then we'll get into the divisions of the ventral cavity in a second. So the posterior aspect is covered, encased by bone. The ventral cavity is encased by what we call a serous membrane. We're going to talk a lot more about serous membranes in a little bit. But basically, it's not a bony structure. It's made of epithelial and connective tissue. And it's really pretty tough. Like if you dissect something, you can see it. It's really obvious where those cavities are. It's not some microscopic thing. Right, so we got our posterior, so the cranial cavity, which houses the brain, and then the spinal cord, which is in the vertebral canal. Would be the two parts of posterior cavity there. And I know I go through these kind of fast. It's because PowerPoints are posted. I don't really expect you to like write everything down that's up there. So definitely print those if you can in advance. You can just make little notes on them where is appropriate. All right, so we got our ventral cavity, and it gets divided a few more times. So the first division is basically in half up and down. And so you can, it's divided into the thoracic cavity, which is up at the top. And then below is the abdominopelvic cavity. And these two are separated by the diaphragm. You can see that, right? So thoracic is in green up there. Here's the diaphragm, and everything below that in red and pink is the abdominopelvic cavity. And the abdominopelvic cavity is divided even further into the abdominal and the pelvic. So you're kind of like this. This last division is somewhat artificial. There's no like real structure that separates the abdominal from the pelvic cavity. It's more just a way for us to divide them. Everything else, though, there's a physical separation in the body. All right, so what's in the thoracic cavity? Heart, lungs, thymus, esophagus, most of, and then the trachea. So that's up there. And then the abdominopelvic cavity basically has everything else you'd think of. So the abdominal cavity, that's the digestive system, the kidneys, the pelvic cavity, large intestine, bladder, and the reproductive organs are down there. probably the best way to remember these is to just draw a picture of it and label it. Probably a lot easier than writing a ton of words down. It's just draw a little picture of a person. Hopefully it's not too much of a stick figure because they will need to have a body for you to mark on there. All right, so one of the interesting things about the body is that there's these special membranes that are lining those, and they provide a lot of protection from different things. And that's what those membranes are for. So we'll start with the heart here. And there's a special membrane around the heart called the pericardium. And these membranes have 3 layers. So the visceral layer is closer to the organ, that's in dark blue. And then there's a cavity, a space between, which is filled with fluid. That's the serous fluid. And then there's another membrane called the parietal layer. And that's going to be true for all of the different membranes we talk about. They all have those same 3 layers: visceral, cavity, and then the parietal layer. So all 3 of those will be there. And the main function of these membranes, is to reduce friction and let your internal organs move around. So you can imagine your heart's pumping, so it's changing size, right? Your lungs are inflating and deflating. You wouldn't want your heart like rubbing on a rib or something when it beats. So this is like your internal little hydraulic cushions all over.
So are all the layers and cavities together pretty much make up the pericardium?
Yeah.
Also,
No, you're right. So this together, like the dark blue and the green going around the heart, is the pericardium, which is what we'll get into. So there's your pericardium. And kind of the trick to remembering these is if you can remember that second word, like pericardium, all the other words are just are the same. Because you've got the parietal, and you know that that's the outer layer. And then you've got the cavity, which is the middle, and then the visceral, which is the most internal membrane. And it'll be the same for all of them, just a different noun after it. So that's the pericardium, surrounds the heart. And if you notice, it doesn't go above the heart. It's only on the sides and the bottom. So for example, when they're like doing open heart surgery on people, they do have to cut through this pericardium, do the surgery, and then repair the pericardium back to normal. And one of the risks for heart surgery is that can get infected.
can you live without pericardium?
You
Or is it
can.
really risky though?
I think it's somewhat risky. But in some cases, they can take it out, and it's not like you die or something right away, but you're just a little riskier.
More susceptible to infection.
Yeah. Right. And then there's also a serous membrane around the lungs, and that's called the pleura. And so once again, parietal pleura is the outer layer, pleural cavity with the fluid is the cavity, and then the visceral pleura is that inside membrane touching the lungs. So visceral closer, parietal farther away. And then the peritoneum is the one that goes around the abdominopelvic cavity. It's kind of interesting. So when we dissect our rats, you'll peel the skin off, and then you'll see this sort of translucent, huge like sac basically that all the organs are in. And that'll be the peritoneum. And then visceral, parietal, cavity, just like all the other ones. So really all you have to memorize is that one word for each. You got the pericardium, you got the pleura, and the peritoneum. And if you know those 3 words, and you know which order it goes in, visceral, cavity, parietal, then you'll have it for those. All right, so what's the correct order of structures? moving outward from an organ like the heart or the lungs. All right. Quite a shift to A there, and A is the right answer there. So it goes visceral, membrane, serous cavity, parietal membrane. VSP. Let's see if you can remember that. All right, so the last thing for this chapter is probably the hardest, and that's homeostasis and feedback systems. This is the first time you'll see it, but you'll see it over and over again because your body functions as a feedback system in all different ways. So first, the big word homeostasis. What does it mean? Basically, a stable environment. So your body is trying to maintain a stable environment in all kinds of ways.
Is that like sweating and like heavier breathing?
Yeah, so maintaining your temperature by sweating. One example. You're maintaining your blood glucose, the pancreas and insulin, pH, the amount of water, basically anything you can think of. There's some kind of organ system that's keeping it at a steady range. In order to keep it at a steady range, you need to have a feedback system. Because, for example, let's say your body's feeling hot, so it's sweating. The body needs to be able to say, okay, we've lowered our temperature back to 98.6, let's stop sweating. That's what a feedback system is it can kind of tell. If you didn't have that, you would just keep sweating and sweating, losing temperature until you're hypothermic. Obviously, that is not what you want to do. You want to be able to fix the problem, notice that it's corrected, and stop trying to fix it.
Do you have a feedback system? Like you would never start sweating, right?
Well, the feedback system is more usually to stop it. But you're right, if you were lacking, so this could be like a disorder, right? What if you didn't have the first step, the receptor, then you wouldn't respond to it.
Someone is on the sweat glands, and so they can't, like, if they work out, they have to, like, I don't know, they drink a lot of cold stuff, trying to keep their temperature.
Huh, I haven't heard that one before, that's
I saw it on
interesting.
one of my research.
Yeah, so no sweat glands.
Monster inside me. Ew, I hate that shit.
So the brain only is the control center, or are there like other examples?
Sometimes it's a spinal cord, some other places. It's a good question, though. Right, or it could be the kidneys, could be the control center. There's a lot of different places. So the three main components are basically you have to have some kind of sensor to sense that something's off. The blood glucose is too high, the temperature is too low, pH is going high, whatever it may be. And the receptor, it doesn't fix the problem. It tells the next step, which is the control center. Could be the hypothalamus. And the control center gets all this info and decides if something needs to happen. If something does need to happen, control center sends a command to the effector, and the effector is the part of the body that fixes the problem. So if you're talking about temperature, the effector would be the sweat glands, sending out the sweat. We have a few, and an analogy for this is thinking about like maintaining the temperature of your house. You've got a thermometer, which is the receptor. It's sending information to the control center, which is the actual thermostat. And then, if necessary, the control center tells the air conditioner to turn on, which lowers the temperature, and that receptor isn't going to be activated anymore once it gets to the correct temperature again. So that's that one. So that's the general components, and then there's two main kinds. You have negative feedback, which is far more common, but then there's also positive feedback. So we'll talk about negative first. And the key difference for negative is that whatever the effector does turns off the stimulus. So If that stimulus was being too hot, the sweat glands producing sweat lowers the temperature, and now the stimulus is gone because the temperature is back to normal. And usually, for negative feedback, you get back to homeostasis, and then you don't have a stimulus anymore because the effector did what it needed to do, fixing the problem, basically. So we talked some about the temperature already, so we talked about it a little more. And same main things. So for this one, high body temperature, and there's temperature sensors, like neurons in your skin, and also in the hypothalamus that can tell that the body temperature is too high. It sends that info to a part of the brain. So that's your control center. And then the brain tells your sweat glands to sweat. It also tells your blood vessels to dilate. Is dilate getting bigger or getting smaller? It's getting bigger. Why would you want to do that if you're hot? More what? Yeah. It does allow more blood, but why does that help your temperature? Why does that lower your temperature? Yeah, so basically all the things you said, more fluid, more circulation. If you have more blood close to your skin, the blood's going to lose heat faster. So that's why when you exercise, you get red. You get, kind of like red all over if you're really exercising hard. That's because those blood vessels are dilating to get the blood close to the surface. And then you restore your temperature, and that stimulus then is gone. You're back at a normal temperature. So the loop gets turned off. Of course, there's a negative feedback loop for low body temperature as well to warm you back up. But just another example. All right, so which of these is true of negative feedback loops? So there's two that are right. What are they? It is C and D. C and D is right. So they bring you back to homeostasis, and the response decreases the stimulus. That's what makes it negative feedback, is that. That the body's response decreases the stimulus. That's the negative part about it.
Okay. Oh, that makes sense.
And most everything is negative feedback. There's only a few examples of positive feedback. So positive feedback is used to speed up processes over and over, basically. And in this case, for positive feedback, the effector response increases the stimulus. It's a little bit hard to understand. Let's do an example. So one example, most common one, is during birth. So, and by the way, isn't this like the most relaxed person giving birth you've ever seen?
Yeah, no.
She's like, doesn't even notice.
You don't look like that.
I know.
You don't look like that when that happens.
She's like, oh, whatever. So basically the first step is the cervix is stretched, and there's sensors in there that tell the hypothalamus, hey, there's a baby in here trying to get out. Hypothalamus has the pituitary release oxytocin, goes to the uterus, and it tells the uterus to contract harder, which makes, do you think that's making this pressure greater or less? So it's making this pressure greater, which is telling the hypothalamus, hey, there's still something pushing on us even harder, which makes more oxytocin, which makes the uterus squeeze harder. And that would, of course, continue until the baby's through there and out. Well, when would this stop? When the what? So when the placenta is released, when there's not something pushing on the cervix anymore. And so that's makes sense to have a positive feedback loop for this because you want to get, keep contracting that muscle until there's nothing pushing down here anymore. Which part? Probably.
I don't know, because I just remember learning that positive feedback has something to do with
Like when babies cry, or
Well, probably in terms of like how much milk you're making.
yeah.
It's like the more suckling, the more milk you're making.
Still longer than
That is true. Yeah, definitely.
oh yeah, because after you have,
And oxytocin's also like a binding, like a important in emotional bonding. That's why you've heard from people who've nursed, like they feel so crazily attached when they're doing that. That's a lot of that hormone.
they encourage you to breastfeed right after you because that keeps that going and it helps contract your uterus faster.
Mhm.
So is it like when premature labor happens, is it because the pressure's kind of being checked in the sensory?
No one actually knows why premature labor starts.
Oh, really?
But certainly after the baby starts coming down, that's why it keeps going probably.
Yeah.
But the signal for the start of preterm labor, they don't know.
What's the medicine?
Or labor in general, yeah, I should point that out.
Yeah,
What's the medicine you get when you have
Pitocin.
Yeah, Pitocin makes the uterus contract. What's the key difference between positive and negative feedback? All right, so the 16% of you that stuck with C were correct. What were people putting? F? No, yeah. So the control center's response to the receptor. It is not different. So if the receptor's activated, it activates the control center in both.
No matter if it's positive or negative. Okay.
Right. So the difference is whether that response increases or decreases the stimulus. So were y'all thinking the positive feedback, the control center didn't respond? Or were you thinking the negative feedback, it didn't respond? Responding differently? So let's go back to that one real quick. So our negative one. So if that receptor senses that it's hot, it tells the control center to do something about it. And then the control center does something about it. For the positive, if this receptor senses something pushing on it, the control center is told to do something about it. It's going to contract that muscle. So the only difference is that the response is going to decrease or increase that stimulus. So the next thing you have to worry about is your pre-lab quiz that I'll be posting today. And it's going to be on D2L, open note, no time limit. And it'll be about lab number, which lab are we doing next? Number 1. We did 3. Now we're going to do 1.
Do we need to have safety glasses for